All right. Hi, Tigers. Today we are going to learn about percent of change and percent error. In our book, this is two separate sections, but they're very similar, so we're going to do them on the same day. So percent of change is measuring what percent something increases or decreases. And we calculate that by finding how much the number changed and dividing it by the original number or the one it started at. So let's try some examples here. It says to find the percent of change from 25 to 49. So first we need to know how much that number went up. And to find that, we would subtract to get 24. So the change in the number from 25 to 49 is 24. And then we're going to put that over the original number, which is 25. It started at 25 and went up to 49, so it changed by 24, and the original was 25. So you can just put that into your calculator, 24 divided by 25, to get 0.96, and as a percent, of course, this is 96%. So even though I used a calculator, I still want to see that much work. To go from 50 to 45, it changed by 5. So I'm going to do 5 over the original first number, and I'll divide that in my calculator to get 0.1, which is 10%. Example 2 says Susie purchased a daily planner for $32. The wholesale cost was $25. What was the percent of increase? So we want to know how much did the price go up by just subtracting the two prices. So the change in the price is 7, and it used to be 25. That was the original amount because it was bought for 25, and then the store marked it up to $32. So if we want to know how much it increased, we're going to divide 7 by 25. You can do that in your calculator, or another way you could do that one is find equivalent fractions that have a denominator of 100, and you'd get 28 over 100, which is also 28%. But I just divided it on the calculator. Example 3 says Carlos used a coupon and paid $7.35 for pizza that normally cost $10.50. What's the percent of decrease? So first, let's find out how much that price changed. Or this, another way you could say that is to find out how much he saved, right? So I'm just subtracting that on my calculator. So the price changed by $3.15, and it was originally $10.50. So let's divide those numbers on the calculator. I get 0.3, which is 30%. Now, sometimes you don't get nice, neat percents like this, and you'll have to round off and look for, what it asks you to round to, the nearest whole percent or 1/10 of a percent. But these are coming out nicely right now. When Bobby was experiencing, exercising. Remember, I never go back and start my videos over. If the dogs are barking or I do something wrong, we fix it, we move on. I don't have time to make a new video. So when Bobby was exercising, his heart rate went from 79 beats per minute to 98 beats per minute. What was the percent of increase? So let's first see how much his heart rate changed. 19, right? All right, so then we're going to do the change over the original. So it went from 79, and it also says that it increased, so we know the original is the smaller number. So I'm going to go ahead and put this in my calculator, 19 divided by 79, and here we go with a not so nice one. I get this big, huge number. Just keeps going on and on and on in my calculator. It does not tell you what to round to, but I would say to the nearest whole percent probably. So we'll do 24% there. All right, that is the percent of change, also called percent of increase or percent of decrease. Now let's talk about percent of error, that's basically the same thing. So percent error means like if someone estimates a number that's gonna happen and it's off by a little bit, you can calculate the percent of error, seeing like what percent are they off by. So again, like percent of change, you're gonna subtract the estimate and the actual and find out how much like the change or the error was. And then we're gonna divide that by what the actual one was. So Mrs. Mandel predicts that 10 out of 30 students will earn an A on the test, but actually 12 students earned an A. What is the percent error of Mrs. Mandel's estimate? Round to the nearest 10th percent if necessary. Okay, so we've got 3 numbers in here and we don't need them all. She predicts that 10 students will get an A, but actually 12 students got an A. So first, let's see how much she was off by. What's the error? She was off by 2. And then we're going to divide by the actual number of students who got an A. So in my calculator, I'm going to do 2 divided by 12. They're going to get 0.166. It's going to repeat. So it says to round to the nearest, 10th, which is right here. So I'm going to look one place over. Wait, just kidding. First, I have to change it to a percent, which means I need to move the decimal over. My goodness, twice to the right. So this is what I get as a percent. But it says to round to the nearest 10th of a percent. So this is just going to keep going and going and going and going. So here's the 10th of a percent. We look one place to the right. Since it's 5 or more, we round up. So it's going to be 16.7%. That's the percent of error. So the estimate was off by 16.7%. Let's try our last example. A package of candy should have 125 pieces. When it is checked at the factory, there are 118 pieces. So what is the percent error? Round to the nearest 10th percent if necessary first. So let's find out how much it was off by first. It's off by 7. And then we're going to divide by how many pieces were actually in the package. So 7 divided by 118 on my calculator looks like this. And it's longer and longer. So first we're going to change it to a percent by moving the decimal twice to the right. And then if we want to round to the nearest 10th, we're going to look at the place just to the right. Since it's less than 5, I'm going to keep the 9. And it's off by 5.9%. That's the percent error. All right, guys, thanks for watching.